Hello friends, it's Uncle Sam again, and today we'll be treating or we'll be solving questions on ordinary differential equation or ODE. So what is ODE? ODE is a kind of math equation where you have y, for example, which is a dependent variable in form of x or time, which is an independent variable. So you're trying to say how is the dependent variable changing with respect to the independent variable. For instance, okay, so it's ODE, ordinary differential equation. Okay, so for example, if you have the y dx to be, let's say 3x, you're trying to say how is y changing with respect. So you're trying to say y is changing with respect to x in form of 3x. That's what you're trying to say. And if you have this kind of equation, you want to be able to get the value of y as something as a function of x. So instead of having it in a differential form, we want to be able to change it to a form of equation, like just having y equals something. Y equals, you know, function of x, maybe x squared plus 5x. You know what I mean? So you don't want to just have the y dx because for real, you don't even understand how it's really changing or for example, you want to draw this graph, it's better you draw a graph y with respect when you have y equals to something like x raised to power 2 plus 5x than just having the y dx. So you're trying to, you know, simplify a differential equation, and that's what the topic is all about for real. So let us solve this particular equation. And before we jump into the equations, I would like to let you know that it depends on the kind of question you're given, and um, you be able to know the kind of method you're supposed to use in solving the equation. The simplest form of the simplest method to be able to solve a differential equation is the one we call the variable separable. It is the easiest and it's like the starting point of solving ODE. So for example, if you're given, okay, let me just call this variable separable. So we're going to be solving a lot of questions on variable separable for now, for this first episode. Separable, yeah. So you're going to be solving a lot of questions. For example, let's say the y dx equals x raised to power 2, y raised to power 3, and you want to be able to solve, this particular equation. Variable separable is trying to tell you that you can set variables apart from another variable. For example, you set y to one side and you're going to sort x to the other side of the equation. So you have the y here and you have y here. So you move y down here. Then you have the x here and you have x squared. So you move the x down to the right hand part of the equation. So if you're moving y raised to power 3 to the other side, you have 1 over y raised to power 3 dy equals x raised to power 2 dx. So because you have this, you have the y here and you have x here, the best way here is to just integrate both sides. So you're going to integrate both sides. So you're gonna integrate both sides. So let's divide this into two here. This particular one means, okay, so let's put the integral sign. 1 over y raised to the power 3 dy equals what? Integrate x squared dx. And don't forget the constant at the other side because you're integrating. Here also, 1 over y raised to the power 3, if you remember the law of indices, it's going to change to minus 3, right? Dy equals what? Integrate x raised to the power 2 dx plus c. And from here, if you remember the law, or let's say how to integrate, if you still remember how to integrate, you're going to add plus 1 to the power, and your value here, your answer here, you're going to divide this whole thing by the value you get here, and also the same thing you're going to do here. So here you're going to say y minus 3 plus 1, and the same thing you've written here, you're going to write it here, plus 1 equals x2 plus 1 over 2 plus 1 plus c. So for the second page, this is going to change to what? So this is going to change to y minus 2 over minus 2 equals what? X raised to the power 3 over 3 plus c. So you can multiply all through by minus, and so you're going to have y minus 2 over 2 equals minus x raised to the power 3 over 3 plus c. And from here you can say 1 over, so it's like we used the indices law. So it's like we're doing the inverse. So it's still indices law. So if you remember the indices law, you're trying to say 1 over 2y squared equals what? Negative. Oh, sorry. Don't forget this negative. Um, put negative here because you actually multiply through by negative. And here you're going to have minus x3 over 3 negative c. And from here, we can say we want to find the LCM here. 3 here, we have minus x3 minus 1 here, we have minus 3c, which is what? 1 over 2y squared. And you can, you can put this in inverse, or let me say, because now we have our y, so we want to be able to get our answer in form of y. That's what we're trying to do. So you want to bring 2y squared to be the numerator and 1 to be the denominator. So you have 2y squared over 1 equals what? 3 over, so you can just say negative and put negative in front and say x cube minus, let's say plus 3c. Yes. So we can say y squared equals what? You can bring this to downward. Minus 3 over, that's 2x cubed plus 2c. I can also say y squared equals what? Minus 3 over 2x squared x cubed plus 4c. Oh, sorry, it's 3 here. Don't forget this 3. I brought it down as 2. So 3c, so you have 6c here. And you can just divide through by, let's say, by 3. So y squared equals minus 1 over, let's say, um, minus 1 over 2 over 3 x cubed plus 2c. Okay. Okay, so now we have, so now if you want to be able to have this as a positive value, so you have y squared equals 1 over um 1 over 2 2 over 3 2 over 3 x cubed. We can just say negative negative here, then 2c, right? Um, you can change this to, let's say, another constant, which is k, because it's constant. So y squared equals 1 over, let's say, k minus 2 over 3 x cubed, and your y can be the root of 1 over k minus 2 over 3 x cubed. Yeah, so you've gotten your answer in terms of y as a function of x. Thank you very much. Or you can also say, so because you have 1 here, it can also be, oh, don't forget plus or minus. Or you can say roots plus or minus. No, let me go back. Plus or minus 1 over k minus 2 over 3 x cubed.